Picture this, a swirling vortex of clouds, rain and wind spanning hundreds of miles. It's a typhoon, a behemoth of nature capable of unleashing unimaginable fury upon the world. These aren't your everyday storms. We're talking winds that can make buildings tremble and waves that crash over coastal cities. But what exactly is a typhoon? Simply put, it's a type of tropical cyclone. Think of it as a giant spinning top fueled by warm ocean water. Depending on where they form, these storms go by different names. In the Atlantic and Northeast Pacific, we call them hurricanes. Over the Northwest Pacific, they're known as typhoons, and in the South Pacific and Indian Ocean, they're cyclones. Same beast, different name tags. Now, you might be wondering, are some storms stronger than others? You bet. We measure their intensity on something called the Saffir-Simpson Hurricane Wind Scale. It ranges from Category 1, still dangerous, to a terrifying Category 5. These storms are not to be messed with. Typhoons are a stark reminder of the immense power of nature. They can reshape coastlines, devastate communities, and leave a lasting impact on the environment and human history. But despite their destructive potential, typhoons are also a fascinating meteorological phenomenon, a testament to the complex and interconnected systems that govern our planet. So how do these swirling behemoths of wind and rain come to be? It all starts with a recipe that even the pickiest storm would approve of. First, you need a generous helping of warm ocean water, heated to at least 80 degrees Fahrenheit, 26.5 degrees Celsius. Think of it as the fuel that gets the storm engine revving. Next, add a dash of low-level convergence, where winds from different directions collide. This forces the warm, moist air upwards, like a hot air balloon eager to take flight. As the air rises, it cools and condenses, forming thunderclouds that reach high into the atmosphere. The Earth's rotation adds a bit of spin to the mix, thanks to something called the Coriolis effect. This transforms the rising air into a swirling vortex. As the storm gathers strength, it acts like a giant vacuum cleaner, sucking in more warm, moist air from the ocean's surface. This fuels the cycle, causing the winds to spin faster and the storm to grow in size and intensity. And voila, you have yourself a typhoon, but like any good recipe, there are a few secret ingredients that can make or break a typhoon. Factors like wind shear, changes in wind speed and direction at different altitudes, can either enhance or disrupt the storm's development. Typhoons have left an indelible mark on human history, often serving as stark reminders of nature's raw power. One such event that stands out in recent memory is Typhoon Haiyan, known in the Philippines as Super Typhoon Yolanda. In early November 2013, Haiyan slammed into the central Philippines, unleashing its fury with wind speeds that reached a staggering 196 miles per hour, 315 kilometers per hour. It was one of the strongest tropical cyclones ever recorded to make landfall. The devastation left in Haiyan's wake was catastrophic. Entire coastal communities were reduced to rubble. Trees were uprooted like twigs. Over 6,000 people lost their lives and millions more were displaced from their homes. The storm surge, a wall of water pushed ashore by the typhoon's powerful winds, was particularly destructive, inundating low-lying areas and causing widespread flooding. Haiyan serves as a stark reminder of the immense destructive potential of these storms, particularly in a world grappling with the impacts of climate change. The storm highlighted the importance of disaster preparedness, early warning systems, and resilient infrastructure in vulnerable regions. It also underscored the need for international cooperation in providing aid and support to nations reeling from the aftermath of such catastrophic events.